Okay, good morning, class. We're going to be looking at uh, arc measure today. A few of you asked me questions about this, so here we go. We're going to look at arc measure and how to find it. So here's a problem from Khan Academy. I'm going to go through a few of those. Let's look at some vocabulary. The first one that we're going to look at is a central angle. Like, what is a central angle? So I'm just going to take a look at a central angle. The vertex is at the center of the circle. So actually this 155 degrees is part of a central angle. The angle that we're looking at would be this one right here. Angle APD is a central angle. There's a number of central angles, like APB is a central angle, but we know that that's a central angle. And the next one is the degree of a minor arc, and that equals the degree of its central angle. So if I wanted to find out an angle in this one, I know the central angle, so I know that this angle, this arc right here, has a measure of 155 degrees. So so let's just put that in 155 degrees. So that arc has 155 degrees. And the next vocabulary word is, well, we want to look at some special arc measures. A whole circle is 360 degrees, and a semicircle is 180 degrees. Now, a semicircle is half of a circle, and we could always identify that because it's like a diameter. So let's look at a diameter like this one right here. That's a diameter. That's 180 degrees. It's a straight line. So the arc measure of this one right here would be 180 degrees. So that's 180 degrees. So there's a couple of things that we can look at in this diagram. We could say this angle is 155, this angle is 180. And that might give us a way to find this missing angle over here because the whole thing is 360. Anyway, that's some vocabulary. Let's go ahead and just do this problem, and then we'll do a few more to see. So the first thing is that we're trying to find the measure of arc BDC. Now, BDC would go from B to D to C. So I can't go around this way because that's BCD. So BDC would go this way. Okay, BDC. So in order to find that arc, we're going to have to find out what this little piece is right here. Probably we could find maybe that. So here's a couple ways that we can find that missing piece just by what we've written so far. And the first thing is I would say, okay, we have this angle plus that angle. So 155 plus 180, and that would be 335 degrees, and that's how far it is all the way around those two angles that I did. So if I take 335 and subtract that from 360, I get 25 degrees, so I find this is 25 degrees. Now we could probably also use the idea that that these are vertical angles, so this one's also 25 degrees over here. So there's a couple of ways we can do that. So now let's go ahead and find the arc that we want. So I'm just going to erase these marks that I made, and I could just see that the arcs here that I need. And we're going to look at this particular arc that we want to find, and that is arc BDC. B to D to C. Now, if I look at that, it looks like there's a semicircle to there. So I know that there's 180 degrees all the way around here, and then there's 25 degrees more. So when I do this, I can just add those two together, and I got it. So if I do 180 plus 25, that's going to give me 205 degrees, and that should be the measure that I'm looking for. So the measure, I would write it this way, the measure of arc BDC equals 205 degrees. Okay, so I hope this is helping. I'm just going to kind of whip through some problems here. In this case, AB is a diameter again, and this time we're finding this arc right here. So we want to find this arc. Why don't you go ahead and try this one? It's always good to try it yourself. You could just see how would you find that arc. Okay, and you could You can pause the video if you want to and solve for that. I'm just going to do it right now. Okay, so that is what I got. The measure of arc AC equals 111 degrees. Okay, there it is. Okay, let's look at another one. Now, this is a little more complicated, but what if we want to find the measure of AEB? So let's go ahead and look at what that is that we're trying to find. That one is A, E, B. Okay. All right, so now we're going to have to figure out what this piece is right here. So it might be possible for us to figure the rest of it out. I'm going to look at this again and say, there's a number of ways to do this, but we need to find all these angles here. We might notice that there's some vertical angles in the problem because there's two diameters. So in this case, these two diameters create two vertical angles and two pairs of vertical angles. So that might help me out. Might want to know that I could put the arc measure on the edge of the circle. It usually helps to do this. So this is 93 degrees. Now I might notice that that one plus this one is 180. So I mean, I could write it as the measure of arc DE plus the measure of arc EA makes a 180 degree angle. So now I could put this DE in as 93 degrees plus this one, the measure of arc EA, equals 180 degrees. So I'm doing it a little bit more formally now. So maybe that helps some of you. Minus 93. So I have the measure of arc EA equals, subtract those, and I should get 87 degrees. I think that's right. Okay, so now I found this one's 87 degrees, and so by vertical angles, I know this one's 87 degrees, and now I can go ahead and find my arc that I want. Here, that major arc. So that is, well, this one's 38 because it's there. So we have 38 plus 87 plus 93 plus 87, and that would give us the measure of the arc. So add those up. I think I did that right. So the measure of arc AEB equals 305 degrees. See if I did that right. So it's 5, that's 13, 22, 30. Okay. All right, let's look at another one. Okay, so what is the arc measure in degrees of DC on the circle below? In this case, it doesn't identify any diameter, so that's probably not a diameter. So that means that it's tempting to say that that's 70 degrees right there because it looks like a vertical angle, but if that's not a straight line, then we don't know. And it kind of looks like it's not, and that's not a straight line either for sure. So we don't know that. So let's go ahead and see what we can do if we want to find this arc measure ADC. So let's see what I have. Highlighter. So ADC. Oh, well, that's actually just the other part of this arc. And I can find this arc. So I know these two arcs make a whole circle and add up to 360 degrees. So that gives us an idea of how we can find this angle. We could just add 104 plus 70, and that gives us the blue angle. So that is 174. So this blue one is 174, and that's my blue arc there. Now, if I want to find the other one, I would subtract that from 360. So 360 minus 174, and then I would get my answer. So let's just do this. It's good practice. Borrow, that makes that a 5. Okay, this is a 6, and then we have to borrow again. That's a 2, makes it a 15. That's an 8, and then that's a 1. 186. So that's 186, and this one's 174, and that makes 360 degrees. The arc that I want, the measure of arc ADC equals 186 degrees. Okay, moving right along, I'm trying not to waste too much time here. We're going to look at a couple of problems with variables in them because that's the other thing we need to do. So we kind of set it up the same way, but we know that AB is a diameter. So let's make sure that we know where our diameters are. So I'm just going to say this is a diameter of the circle. That means I got two 180-degree arcs. I got one up here and one down there. So I'm just going to highlight this one because this kind of involves the angles that we need. This arc is 180 degrees. So now I can set up an equation to say these three angles is 180 degrees, and this one's 90. So we can say this is a 90-degree arc, this one is 9x minus 7, and this one's 7x plus 1, and we need to find a specific arc here, but let's set up our equation. We have 7x plus 1 plus 9x minus 7 plus 90 degrees equals 180, our semicircle. Okay, then we just combine like terms and we get 18x. No, it's 16x. Okay, 16x, and then 1 minus 7 is minus 6 plus 90. Combine those like terms, I have 16x plus 84 equals 180. Continue to solve, subtract 84. If I'm going too fast, you can always slow me down. Anyway, this is a 16x, and this is a 96. Divide by 16. So x equals what? 6? 6 times, yeah, that's right. So x equals 6. So that's not the answer. It says what's the measure of AD? So let's look at AD. The measure of arc AD equals 7x plus 1. So we just plug that into this x right here. And so we have 7 times 6 plus 1. And that equals 42 plus 1, which equals 43 degrees. Okay, so that's our answer, 43 degrees. All right, let's look at the last one. Hopefully I'm not going over time. All right, maybe I'll just set this one up and we can see it, but you should try this one on your own. What is the measure of arc CD? That's this one here. We do have two diameters in the problem. Let's make sure we know where those are. Let's see, this is a diameter BE, and this is a diameter AD. You can always identify those because they go through the center. So even if they didn't tell us this, we know that those are diameter because those are straight lines through the center. Now, there's a couple ways to do this one, but one thing I might notice is if that's a right angle, then this one over here on the other side must be a right angle as well. So I just instantly know that I've got a right angle here, and that makes an equation that I could solve. So I have 33k minus 9, okay, 33k minus 9 equals 90 degrees, because this arc, this one's 90 because of that angle, and this one's 90 over here. So this is the same as that. So that's what we do. So we just add 9 to both sides, and we're going to get k. So 33k equals 99 divided by 33, and k equals 3. Okay, and then we can find CD. CD is this one over here, so we just have to plug it in to this equation. So this would be 20 times 3 plus 4, and so that would give us the measure of arc CD equals, that would be 60 plus 4 is 64 degrees. Always check to see if that makes sense in your diagram.